Alright, I had a request to kind of go over problem 13, which was very similar to the last problem on the notes that we did. There's a lot of formulas that, well, there's three formulas that come from the distance formula. Distance equals rate and time, which all that means is if we have a rate and time, we can represent it as distance. And if you solve it for a rate and you solve it for time, this just means that if I know distance over time, or distance and time, I can set up something that is equivalent to rate. And if I know distance and rate, I can set up something which is equivalent to time. So I'm going to go ahead and read this, and I'm going to end up using this guy right here, time. Alright, so we're going to use this formula very soon. And hopefully it'll make a little sense to you. Let's set my camera up here. Hopefully it is in a situation that kind of might even get a little closer. Let's see if I can get this a little closer there. And I will read this. Alright. It says, a riverboat is traveling at an average of 14 kilometers per hour in still water. Alright, so I wrote that, how fast it travels. The riverboat goes 110 kilometers up the Ohio River and 110 kilometers down the Ohio River in 17.5 hours. So this gave us a lot. Alright. It gave us a total miles, 110 and 110. It gave us total time, which we're going to end up using right here. And it also gives us the concept, right, that you're traveling up a river and down a river, and it sets it up for this final question. So nearest tenth of a kilometer per hour, what was the speed of the current? So now you have to understand some basic physics of the matter here, is that when you go up a river, the current slows you down, so this base speed is slowed down by the current. When you go down a river, the current speeds you up, so this base speed is sped up by the current. And since we have, look over here, we have both distance, 110, upriver and downriver, and rate, 14, I can re-represent those as time. So I could literally say time upriver, right? Time upriver is distance divided by rate. It's 110 divided by 14 minus c. And likewise, I could say time down river is going to be 110 over, 14 plus c. What that allows us to do is, this is obviously the total time. I mean, all it did is go up and down river. So we can compare, I'll just say time up plus time down. Oh, I should have said that TD. Time down is equal to total time. And that's just kind of a brief, kind of what I'm going to write here. So time up, right? Time up was 110 over 14 minus c, plus time down, 110 over 14 minus c is equal to the total time, which they just happen to give us, 17.5, and these are what, hours? Hours. Alright. So, here we go. Alright. Very first thing I have to do, and I'm going to do, I've done a lot of the math preemptively, but I'm just going to tell you where the math ends us, is we got a least common multiple, which is every denominator you see, so it's 14 minus c times 14 plus c. We're going to multiply both sides by that. We're going to multiply 14 minus c and then 14 plus c, right? Just like that. On this side, and over here the same thing. This is going to be times 14 minus c and 14 plus c. Well, on this side, we literally get, all right, if we multiply this side by 14 minus c and 14 plus c, we are going to get 17.5 times 14 minus c, right? And we're also going to get, right, that times 14 minus c, which I have already written. But this guy's a little bit different, right? So I want to point out something, that when I distribute to here, right, these 14 minus c's cancel out. All right. So what that gives me is it gives me, right, 14 plus c times 110. So 14 plus c times 110, I'm going to write right here, I'm going to write 110 times 14 plus c. Plus, when I distribute to this guy right here, right? When both of these come over here, these guys cancel out. What that gives me is 110 times 14 minus c. If you look at that, I'm just going to look at the c's because these are opposite signs. That's 110 times negative c. That's 110 times positive c. Those guys are going to cancel out. So basically you have 28 or 14 times 110 plus 14 times 110, and I'm going to give you that total. It's something you could do in your calculator, right? But that's going to be 3,080 if you work that out. And then over here, if we multiply this through, we're going to get 3,430 minus, all right, 17.5 c squared. And that's realizing that I'd probably multiply this before and then bring that in. Just run it a little so it's low on space. But I think all of you know how to multiply all these guys together. Foil this and then multiply everything by 17.5. So there's a lot of options from here. If we subtract 3,430 from 3,080, I get negative 380 equals negative 17.5 c squared. If we divide by negative 17.5 c squared, we get 20 equals c squared. And the square root of that is going to be about plus or minus 4.5 c. We're just going to keep everything as positive. So we're going to go 4.5 kilometers, I believe, per hour. And that would be the answer to that equation. All right. So I'm going to post this. This will be my first posting with this camera. I hope it works out all right, and I'll talk to you guys soon.